One of the most important features of functions, or even just relations, they don't even have to be functions like circles, is the concept of domain and range. And domain is just the sets of all permissible values of x. You always want to know where you can function, where you can play. For example, if you play basketball, the courts would be your domain, so to speak. That's where you can play. So you're not allowed to play outside of the rectangular basketball courts. So domain in mathematics is the sets of permissible values of x. And the range is the exact same thing, it just focuses on the y values. So it is the set of all permissible values of y. Now, before I begin, let me just say something quickly. You can find the domain and the range of any function or relation, or I should say of most functions or relations, either through the function itself. Let's say I give you f of x equals x squared, okay? It's not hard to find the domain from the function. It's a little harder to find the range from the function. However, if you are able to graph them, or if the graphs are provided to you, then it's not hard at all to figure out the domain and range. Okay, so I'll repeat it in a different way. If you are given a function, it's not hard to find a domain. If you graph it, it's even easier to find a domain. On the other hand, if you are given a relation or a function, it is not easy to find the range. Sometimes it is impossible, but it's definitely harder than domain. If you are able to graph it, let's say like this graph, then it's not hard to find the range. So what I'm going to focus on today is I'm going to give you a bunch of graphs like these two, and then just through the graphs, we're going to try to figure out domain and range. Make sense? Okay, so let's just assume I have a function, I called it f, and it goes from this point to that point. Notice that the endpoints are closed, they're not open, okay? So the domain is the set of permissible values of x. So if I were to collapse this curve on the x-axis, it'll fall exactly where the green color is, the shaded region, shaded interval. And it goes from that's x and that's y. So you don't want to look at b or d. You want to look at a and c. It goes from a to c. So your domain is this. And your range will go from b, which is the lowest value, to d, which is your highest value. This is your range, visually speaking, and this is your domain. How do you write it? You could write it in the interval notation, or you could write it in the set notation. You have a choice. Okay, so the way we say it is the domain, capital D, subscripts the name of the function, in our case it's f. Domain of f is the interval from a to c, inclusive. I put brackets. If you put parentheses, that means you don't include that endpoint. So for example, if I say this point here, 1, comma 2, like this, it refers to this interval. It is open on the endpoint called 1, and it is closed on the endpoint called 2. Okay? So that shouldn't be hard to say, right? And then in the set notation, you say the set, brackets, right? It is a family. A set of x such that, colon means such that x is stuck between a and c, inclusive. I have to say less or equal, because you don't have holes. The same thing with the range. It's the interval from b to d. You always go from small to large, small to large, small to large. The range, capital R, of the function f is the interval, closed interval from b to d, or it is the set of y. Domain always works with x, and the range always works with y. Y squeezed in between b and d. Okay, so here is another one. It is a function f. It has an endpoint here, but it's open, and that arrow means it just keeps going forever, right? So the domain, if I were to collapse this curve on the x-axis, it'll start at 0, but not including 0, because this is a hole. Don't look at b, look at 0, this one, all the way to infinity, right? So these red dashes don't end. There is an arrow there. So how do you say it? You start with 0, that's your smallest, non-inclusive, and you go to infinity. You never closed the infinity. You should never do something like this. Those two don't work together because you never reach infinity. Infinity is just a symbol that stands for a number greater than any number. So because you don't reach it, it is always open. This is always open. This one is open because this is not filled. If it was filled, then you could close 0 like we did here or here or here or here. Okay? How do you say it in the set notation? It is the set of x that is greater than 0. That is exactly what I wrote. X greater than 0. Don't write this. Don't say x, set of x such that x is more than 0 and less than infinity. We don't do this, okay? X is a number, 0 is a number, infinity is a symbol. So we don't do that. We just, I'll write it differently. Here's what I just wrote. We don't do this at all. If you don't say anything, it means it goes all the way to infinity. And this is exactly this. Isn't that true? Okay. What about the range? If I were to collapse the curve on the y-axis, it'll start at B and it'll push up forever. So starts at B, not touching B, and pushes up. This infinity is here and this infinity is here. Okay, this is referring to x, this is referring to y. Or you could say set of y such that y is greater than b. Okay. All right, we'll do a few more. Let's say I have a parabola. Maybe I threw a piece of chalk from a height c. I'm not giving you c. And it reaches a maximum of 9 meters after 2 seconds. And then it hit the ground 5 seconds later. Okay, so what's the domain and range? Well, domain, again, we're going to collapse this on the x-axis. Now, initially, if you graph this function, this parabola will continue forever. However, in context, the height cannot be negative and the time cannot be negative. So you don't have quadrant 2, 3, or 4. So everything is restricted to quadrant 1. Okay? From that perspective, and using the context, the domain is the green interval. It starts here at 0, and which is this 0, right? Not that 0. That is the y, that's the x. It's this 0 all the way to this 5, right? So it's very simple. Closed interval, because you could have at time equals 0, you were at a height of c. So 0 is included. You could also have a height of 0. Clearly, it happens when it is 5 seconds, right? After 5 seconds, you hit the ground. So it's possible to have 0 height. So domain goes from 0 to 5, or this is the set notation. The range goes from 0 to 9 in blue. Now you might say, well, my initial height was c, and I started here. Why wouldn't I write c to 9? Why wouldn't I just take this interval as my range? In other words, why shouldn't this be c, this number 0, c? The answer is after 4 seconds, actually, I don't know, it's not 4. After a few seconds, you will go below a height of c. Isn't that true? In fact, your height is 0 at the end. So you might say, well, why did you give me this point? I gave you this point to trick you. Okay, so the range is not going from c to 9, but it is actually going from 0 to 9. It is the blue region, the blue interval. Okay, x, y. Okay. Now here is a simple function called square root function. Square root function goes on forever. It clearly goes much faster to the right and much slower to the top, right? For example, when x is 0, y is 0. When x is 1, y is 1. And you have to go all the way to 9 just to get a 3. and you have to go all the way to 100 just to get a 10, because square root of 100 is 10. So it's go much faster this way than it does go that way. In either case, it still goes up forever, and it still goes to the right forever, and hence the arrow. So the domain is this green interval, open interval, no, closed interval from the left, but it goes to infinity, 0 to infinity, or set of x such that x is greater or equal to 0. Exactly like this guy almost, except that you don't have an equal sign here. The range goes from 0 all the way to infinity. It's very simple, okay? It's not easy, it's not hard to find domain range from the graph. It is a little harder to do it from the function itself. When I say the function itself means like this. If I just write this and I don't give you the graph, it's not easy to, it's a little harder to find domain and range, especially the range, okay? So I'm giving you this example because of the notation. So let's say I give you a function called 1 over x, and 1 over x looks like a hyperbola. It looks like two pieces, as you will see later. What's the domain? Well, let's collapse this black curve, this h function, it's called h, on the x-axis. It'll fall literally everywhere on the x-axis, except at 0. Notice if you drop the curve on the x-axis, every point will be touched except 0. You will never touch 0 if you drop the block. No matter how close it is to the y-axis, it will always be very, very, very close to 0, but it will never be 0. So how do you say it? Well, you can say it in plain English, all real values except 0. You could say it in the interval notation. Domain of the function h is going from negative infinity, always from the smallest to the largest. Negative infinity all the way to 0, not inclusive, and then we're going to add. So these are sets, so we don't say plus, we put a union sign. You add, you go from 0 all the way to infinity. Basically, you just hop over 0. You go from negative infinity, I'll do it this way. You go from negative infinity all the way to 0, don't touch 0, and then start at 0 without touching 0 all the way to infinity. That's your domain, okay? And that's what I wrote. And it looks a little ugly, and I get it. But you could write the set notation, set of x such that x is not 0. When you say x is not 0, it means x is any value that you want except for 0. If I say I'm not coming at 3, you might think of it as, well, I can come at any time except 3, right? So in English it's a little confusing. In mathematics, if I say x is not 0, it means x can take any value except 0. Okay? There is another notation. You don't see this in books, but it is a universal notation nonetheless, so therefore, why not know it? All real values has a symbol called R. This is all real values. All real values, this one. Just that. Not except 0, just all real values. You could just write R. However, when we write R star, it means all real values except 0. So that's probably a shortcut, okay? So I gave you 4 ways to do it. What about the range? Also simple. If you take the curve and you collapse it on the y-axis, not the x-axis, you'll get the blue shaded interval or line, right? It's going from negative infinity all the way to positive infinity, but you skip 0 again. So it's the same thing I wrote here, except now that the focus is on y. So all y such that y is not 0, or r star, or exactly what I wrote here. Okay? Last one. This is the silliest, the easiest, and therefore perhaps the most confusing. Usually simple things in life are the hardest for people to grasp. So that's why I'm doing this. So let's say I have silly constant function, y equals 4. 1, 2, 3, I'll write it down here. 1, 2, 3, 4. So the graph of y equals 4 is just a horizontal line, right? I called it f of x, so I can label the function. Domain of the function f, okay? What's the domain? Domain is silly. This line drops on every point on the x-axis, so therefore it's all real numbers. Okay, you can write this, you can write it like this. You can write it in the interval notation, goes from negative infinity all the way to positive infinity. The range, on the other hand, is a little tricky. If I take this line and I collapse it on the y-axis, it'll fall literally just at a point called 4. So the whole range is just one value called 4. Now what you don't want to do is say something like this. The range of the function f is 4. That is a set. That's a member. And a member can never be equal to a set. A set has to be equal to a set. The way you write the set 4, you put brackets around 4. Now it's correct. Now it's equal. Okay? Remember, this is a family, and this is like a member of a family. So you gotta put it in a bracket. It's almost like a family that has one person that lives in it, and his name or her name is 4. Okay? Set equals a set. You don't say a set equals a member of the set. Okay? So this is your range, and that's your domain. So that should do it for now. All right? Take care.